All right, so for section 9.1, I'm going to give you all what we call interval notation. So this is the review of interval notation. And this is another way to write our domains. So we're actually going to use the infinity symbols to write our domains with now, instead of x, such that x is a real number and not equal to. So what y'all been doing now, we're going to change the game. So in interval notation, to represent all real numbers, we use parentheses, negative infinity, comma, positive infinity, close parentheses. Okay, so this is all real numbers. As far as I can go toward the negative direction, as far as I can go to the positive direction, okay? So this is now how we're going to represent all real numbers. Now, sometimes we got to kick a number out of our domain, especially if we're dealing with fractions. So to exclude values, from the domain, we use the union. And the union is just a upside down looking U. And that union actually means and. Okay. So let me show you an example. So for example, to exclude any number A from the domain, we would write negative infinity to that number. Now, since I'm excluding A and it cannot include A, these curved parentheses mean that it cannot equal that number. Then I'm going to union it and go from the number I'm excluding to positive infinity. So this means you can go from negative infinity. Now, negative infinity always uses parentheses, but in the future, when I want to include a number in the domain, and that'll be later on in life, I'm going to use a square bracket. But when I use curvy parentheses around a number, that means it cannot equal that number. So we can go from negative infinity, kick out the A, which made it undefined, and then from there go towards positive infinity. So it's like it's breaking it into little intervals, okay? So if I was going to exclude 5 because it made my fraction undefined, I would go from negative infinity to 5, parentheses, union that, parentheses from 5 to infinity, okay? Now, I'm going to start 9.1. In the first 3 problems, we don't have to do the domain. But when we start number 4, they're going to be wanting us to find the domain, and we're going to write it in our interval notation, okay? So remember, all real numbers will be negative infinity to positive infinity. Every number I kick out, I'm going to do a union around. So if I kick out 2 numbers, I will have 2 different unions in it, okay? And I'm going to go left to right on my numbers. All right, so you'll see what I'm doing when I hit my domain question. So for now, we want to start 9.1, which is called the composition of functions. So when I think about composition of functions, I sort of think about physics and some of them physical science classes that y'all might get in the future. Sometimes in physics, you got a formula for, say, force equals mass times acceleration. But first, in order to use that formula, I might have to figure out what the mass of something is. So I might have a formula for the mass. I figure it out, plug it into my force formula, get my final answer. So this is going to be where we plug one function into another function, okay? So there's two types of notation we need to know. First is F compose G of X. Now, that's not a multiplication dot. What this is, almost looks like a degree symbol in the middle. This is what we call a composition operator. So when you see something like F compose G of X, that really means F of G of X. And if you remember doing these following order of operations, we would work the innermost parentheses first. So we would find G of X first, and then the answer from G of X, we're going to put into our F of X. So here we would find G of X first. Then we put that into the F of X equation. Into what I meant, F of X. So we would find G of X first, take that answer, put it into the F of X. Second notation, they're going to reverse it and do a G compose F of X, which this one equals G of F of X. So here we would find F of X first. Then we will put that answer into the G of X equation. Okay, so these are two-step problems. In the first example, we find G of X, put it into F. The second one, we find F of X first, put that into the G. So let me let y'all write that down, and then we'll start doing some examples. Now, they're going to start out giving us numbers, which in a way, if they give me numbers, is easier. When I start about number 4, they're not going to give me numbers to put in, and it makes them a little trickier. Because all we can do then is just simplify them, okay? So y'all, let's start over here. So for my first example, they're giving me F of X equals negative 3x minus 1. They're giving me G of X equals x squared minus 2. So for this,
sorry, Professor.
I hear you.
I'm sorry. Can I see it one more time? Can you flip it back? Sorry. Okay, sorry. The G of it.
Right.
Okay.
Yeah,
Thank you. I got it.
Okay.
Thank you.
All right, no problem. Yeah, I ain't able to see y'all writing, so I don't know exactly when y'all are done. So if y'all need more time on any of these, just let me know.
Okay, thank you.
All right, for this one, they want me to find F compose G of X. And you can see why they sort of call this fog, right? Oh, no, not, okay, my bad. We're not finding F of G of X. We're going to find F of G of a negative 3. So put a negative 3 there instead of an X, because they're actually giving us a number on this one, okay? So what this means to us is they really want us to find F of G of a negative 3. Sometimes I write it like this so that I remember to start with the innermost parentheses and work my way out. So y'all knowing that, the first thing we got to do is find g of -3. Once we figure out what g of -3 is, that answer we're going to put into the f, okay? And we'll find f of whatever that number is. So where's my g equation? X squared minus 2. So since you're putting a negative number in, I would put that in parentheses. Put that -3 in parentheses, square it, and then subtract 2. Because when you square any x, it's going to be a positive number unless there's a negative up in front of this x squared. Okay? Any x I put in will become positive when I square it because of like signs. So that -3 squared gives me a positive 9 minus 2. And then y'all, my 9 minus 2 gives me 7. So now we're going to put 7 into f of x. So that'll be my second step on this. So I'm going to find f of 7. So to find f of 7, I take the f equation up here, which is -3x minus 1. Where they got an x, we're putting a 7. So we're going to have -3 times our 7 minus 1. Okay, so two-part equations. Find the innermost, take that answer, throw it into the outer. So y'all, let's see, what's that? -3 times 7 minus 1. That's what, a -21 minus 1.
22.
So final answer, there you go, -22. So this is sort of like stuff that a bank might do. They might have a formula for your balance. And that formula might depend on your debts and credits. So they figure out your debts and credits first, then they put it into the other formula to get your balance at the end of the month. Or a formula for interest, and then plug that in. All right, y'all, so watch this one. They're going to change the order up. This time we're going to find g of f. So we're given f of x equals 3x plus 4. G of x is going to equal x squared minus 3x minus 5. We're going to find g composed f of 6. So y'all remember, that's really like g of f of 6. So for this one, we need to start with f of 6 first. Once I get the f of 6 answer, I'm going to plug it into the g. So here we go. First, we said we're going to find f of 6. So that's going to equal my f equation, which is 3x plus 4. I'm going to put a 6 in for that x. So that'll give me 3 times 6 plus 4. So y'all, let's see, what's that giving me? 3 times 6 is what? 18.
22.
And that'd be what? 20, we're going to say 22. Now, since f of 6 is 22, I'm now going to put 22 into the g of x. So that was f of x. We're putting 22 in for g of x. So we're finding g of 22. So y'all notice the g equation has 2 x's. So for each of them x's, I want y'all to put that 22. So that'll be 22 squared minus 3 times 22 minus 5. So g has still got an x squared minus 3 times its x minus 5. So let's see, I think we can get away with doing the exponent and multiplying on the same step. So y'all, we got to figure out 22 squared. So there's a big one for us. So let me see.
44.
484.
And then we can do this one. Minus 3 times 22 would be what, a minus 66. Minus my 5. All right, y'all, so see what that's going to give me. 484 minus 66 minus 5.
413.
400 and, what did y'all say, 13?
13.
There you go, my final answer. These aren't too bad once you start playing with them. You just gotta watch for the order they're giving us up here. Is it G of F or is it F of G, okay? So let's do one more with numbers. And then we'll start playing with just variables. So y'all, f of x on this one will equal 5x plus 4. G of x will equal x to the third. We're going to find f compose g of a negative 3. So if I was writing that down in short term, it would be f of g of that negative 3. And notice I'm putting these in basically the same order they're giving them to me over here. So that means we're going to first find g of negative 3. So that's going to be an x to the third. So since I got an x with an exponent, I'm going to put my negative 3 in parentheses. And I'll tell you all the truth, negative numbers, 100%, I put them in parentheses. And we're going to cube that. So the question of the day, what does negative 3 to the third power give us?
Negative 27.
Negative 27, good job. Anytime you get a negative number to an odd exponent, it will stay negative like you did, okay? All right, so guess what? We're going to put negative 27 into our f of x now. So that means my second step, I'm finding f of negative 27. So y'all, let's see. Here's my f equation, 5x plus 4. So that's going to give me 5 times x, which is negative 27, plus my 4. All right, so I'm going to multiply first. That's going to stay negative. So y'all, what we get? A negative
Negative 135.
135 plus my 4 for a final answer of
Negative 131.
131. There you go. And remember, math lab, all math lab is going to want is these final answers we're getting, okay? So y'all, let me ask you this. Do y'all have questions on this when I'm throwing these numbers in here? Watch for the order. Always put that number in the first equation, get that answer, put it into the second equation, okay? All right, so now they're not giving me no numbers for the variables, and they're going to ask us for the domains on these. Now, I'm going to find f compose g of x, g compose f of x, so fog and golf, and the domains of each. And guess what? They want our domains in interval notation. And because of that is why I wanted to review y'all in the beginning. So let's see, so all these examples would be like that. So this starts at, I guess, number 4 for your homework. They're going to give me f of x equals x plus 24. G of x is going to equal x minus 24. So we're going to find the fog first, its domain, then we'll come and get the golf part, the G of f, and then its domain. Let's start with the f of g. Now y'all notice they didn't give me a number this time. But we know the f of g of x is like doing f of g of x. So first, we start with g of x. So it gave me g of x is x minus 24. So y'all guess what? Can you do anything with that at all?
No, I don't think you can.
Oh, we can't do none of that because they didn't give us a number this time, right? So guess what's going to happen? We're going to take this whole answer and we're going to put x minus 24 into our f of x equation. So we're doing the same thing, except now it's not a number going in, it's that whole equation. So if we put that in for the x, that means we're finding f of x minus 24. Okay, so whatever we get on our function, if we don't get a number out of it, that whole function becomes the variable for the second one. So y'all, here we go. F is x plus 24. We're going to replace that x with the x minus 24. So that gives me x minus 24. And at the end, it's still a plus 24. Okay, so here's my x, which is x minus 24 plus 24. So y'all, I couldn't do nothing to that first equation. Can I do anything to this equation?
Yeah, you can simplify it, can't you? You can just, because they cancel each other out.
Yeah, that's what, that negative 24, positive 24, good job. They're going to cancel. So my final answer is what?
X.
And there you go. So let me see. I'll help y'all do this domain, and then on the G of F, y'all give me its domain, okay? Or do y'all have any guesses for my domain?
It would be negative infinity. And then what, 24?
Well, let me ask you this. Is there a fraction here?
No,
So you have no fractions. So this is going to go from what? Negative infinity to
Infinity?
infinity. There you go. It's going to work for all real numbers, remember. So we're only still worried about fractions. Now, when I do get fractions, then I'm going to start worrying about numbers to kick out, okay? So let's see if the G of F does. So here we come, G composed F of X. So that's going to be like G of F of X. So the first thing we got to do is find our F of X. You know, let's see, F of X equaled X plus 24. So let me ask you this. Can you do anything to that? And that's sort of like this one up here, right? So the X and the 24, they're not like terms. So that's as simplified as that can go. So you're going to take the X plus 24 and put it into our G of X. So if you notice, they're doing the same thing. It's just this one did the G first, put it into F. This one's doing the F first, putting it into the G. So our second step, we're basically going to find G of X plus 24. So where's my G equation? It was what? X minus 24. So replace the first X with the X plus 24. Bring down to minus 24. So y'all, what's that going to give us?
The same thing.
Yeah, X.
Yeah, because right there, those are going to cancel again. So we get an X. All right, so y'all, this domain is on y'all.
Should be the same thing.
Should be exactly the same. Good job. Cause y'all, if we don't have no fractions, we're just gonna keep going with all real numbers, okay? All right, so let me give y'all a second to write that. Oh, these are sort of fun in a way, because they're sort of like multi-step problems. And it gives you like order of operation type fun and all that. Don't worry, the next one's gonna be really fun, okay? All right, let me let one in real quick. I'll put this down. She was already in. All right, so the same questions. So let me see, this time they're giving us, so we're gonna find the f of g of x, g of f of x, and domains of both. So let's see, y'all, f of x on this one will equal x plus 2. G of x is going to equal 3x squared minus 5x minus 2. So first, I'm going to find f compose g of x, which is again doing f of g of x. That means we got to start with g of x. We already gave me g of x, it was 3x squared minus 5x minus 2. Remember, they didn't give me a number for that, so my question to y'all, does this simplify any?
No.
No, it don't simplify. And you're going to get used to this when you only got x's as the variable and no numbers. You're really not ever going to be able to simplify it on the first step. So guess what? That means this whole trinomial is going to go in for my x's on the f equation. So put this into our f of x. So we're going to be finding f of a 3x squared minus 5x minus 2. So y'all, f equation's right here, right? X plus 2. So in place of that x, let's put that equation, 3x squared minus 5x minus 2. That went in for the x. But remember, at the end, I still got a plus 2. So y'all, what would that simplify into? Because usually on these problems, all you're going to be able to do is just a little simplifying at the end.
Well, can't you eliminate
3x
the two?
squared minus 5.
There you go.
X.
Squared minus 5x. And once again, that negative 2 and positive 2 cancel out. And on y'all's homework, it's going to be the same pattern as I'm getting. You're going to get two numbers that cancel out, and you're going to be left with the x squared term and the x. All right, can't go no further, so that is your final answer. So who's going to tell me my domain?
I'm just gonna-
Negative infinity and infinity.
Perfect. No fractions again, right? So I'm hoping y'all are catching on to me about the fraction stuff, right? All right, so we're going to go the other way. So we're going to find g of f of x. You might see this one's going to be a little funner, okay? Because we got to start with our f of x. Well, you only gave me f of x up here. They said f of x was x plus 2. Remember, that first equation, we're really not able to do nothing to that because they'd probably simplified it before they gave it to me up here anyway. So we cannot do nothing with the x plus 2. So we're going to put this into our g of x. So we're finding g of x plus 2. So y'all know what's scary on this one. You got two x's in the g function up here. Each one of those x's has to be replaced with the x plus 2. So that's going to give me 3 times x plus 2 squared. Now, since you got more than one part, you definitely want to keep that x plus 2 in parentheses as you put it in here. Then it's minus 5 times x plus 2. And then at the end is a minus 2. So both x's got replaced, but it still mirrors 3x squared minus 5x minus 2, okay? And y'all, unfortunately, the first thing I got to do, I got to take this x plus 2 and square it. So I'm going to do side work over here. That way it save me lines over here. All right, y'all, let me add one real quick. All right. So I got to square the x plus 2 first. So we're going to figure out what an x plus 2 squared equals. Notice, I don't have to worry about the 3 being squared because the 3 ain't in parentheses with the x. The only thing we're squaring is what we put in for the x, which was that x plus 2 squared. Anytime we got a binomial squared, we got to write it twice. And then we get to have fun doing a little foiling, right? So x times x is an x squared. X times 2 is 2x. 2 times x is 2x. And y'all remember, I'm multiplying this. So 2 times 2 would give me a positive 4. All right, add like terms in the middle. So I get x squared plus 4x plus 4. I'm now going to replace the x plus 2 squared with this. So bring down the 3. Put in my x squared plus 4x plus 4. And then I'm just going to bring everything else down. Minus 5 times x plus 2 minus 2. Now, the reason I didn't distribute the 5 yet, because hell, I got to distribute the 3 down here anyway. So might as well just do all my distributing in the same row. So y'all, next step, get rid of parentheses by distributing the 3 in the first parentheses. Distribute the -5 in the second parentheses. Anytime you got a negative number in front of parentheses, you gotta distribute that negative also. So here we go. 3 times x squared is a 3x squared. 3 times 4x is a 12x. 3 times that 4 is a 12. -5 times x is a -5x. -5 times that 2 is a -10. And then at the end, bring down -2. Can we go further?
Yeah, we can take the positive 12, the -10, and the -2 out because they're going to cancel each other out.
So these are going to definitely cancel. So anything else I can do?
Can't you add the positive 12x to the -5x to get 7x?
So there you go. You got like terms in the middle. So bring down to 3x squared. 12 minus 5 was what you said, 7x. The numbers cancel because 12 minus 10 minus 2 is 0. So, final answer. I think y'all are starting to get the hang on. Y'all are starting to get the hang of a little bit of this algebra, huh? Not as bad as it was day one. How about that?
Maybe.
All right, so the final question of the day for this one. What's my domain?
There's no fraction, so it'd still be the negative infinity.
There you go. So good job. That's all I'm worried about. Is there any part of my situation where I got them fractions? If not, we can roll with everything, okay? All right, so y'all write that, and then I got one more, but guess what? This last one will definitely have a fraction, okay? Y'all ready?
Yeah.
All right, so this will be like y'all's number 6 in homework. So same instructions, but this time they're giving me f of x equals 3 divided by 1 minus 2x. G of x will equal 1 over x. So I definitely have fractions this time. So let's start out with the fog, which will be f of g of x. So first we're going to start with g of x. And g of x was just 1 over x. So let me ask you at that point right there, that is a fraction. There's only one number I'm worried about going into that denominator, and what would that be?
0?
0. So at this point, we know x cannot equal 0, okay? Now, here's my question. We can't do nothing to that 1 over x, right? Well, this 1 over x, we're going to put into our f equation. So we're going to put 1 over x into our f of x. Which means we're finding f of a 1 over x. So at the moment, we got one number we got to kick out, and that's a 0 because of the first fraction. Now watch this, y'all. We're going to put this 1 over x into the x of the f. That's going to give me 3 on top divided by 1 minus 2 times my x, which is 1 over x. So this one's a sort of tricky one, but the first thing we got to do is multiply that 2 times that 1 over x. And what I do in that, I'm going to show you all a trick. When you're multiplying, I always put a 1 on the bottom of my whole numbers. That way I can multiply straight across. So that 2 only multiplies by the top number. So we're going to have 3 on top. This will give me 1 minus, well, that's 2 on top over 1 times x is x. So that's going to give me 1 minus 2 over x. So let me explain what's going on here. This is what we call a complex fraction, because it's a fraction inside of a fraction. We need this when we're done to look like a fraction with a numerator and one denominator, okay? We cannot end up with a fraction inside of a fraction. So let me show you what I need to do. I need to cancel out this x on this fraction, okay? So what we're going to do to cancel out this fraction, we're going to multiply all parts. Because remember, anything I multiply, I got to distribute. And whatever I do to the bottom of my fraction, I got to do to the top. So we're going to multiply all parts by x, because that's what's creating the fraction. So we're going to come over here, do multiply my top by x. The one down here, I'm going to multiply by x. And then my 2 over x, I'm going to multiply by x. So y'all watch this. What happens to these x's?
It turns into 1 or cancel.
Yeah, they cancel, basically being a 1, like you said. And that was my whole goal, was to cancel that fraction out. So let's see what we get on top. 3 times x is what, a 3x? The bottom, 1 times x is x, minus 2 times that 1 you said would be 2. So now I have a numerator and a denominator like a normal fraction. And that'll be my final answer. So y'all are going to be really similar. You might not have 3 and 2. They might change those numbers up. But you're going to do it the same way. You're going to multiply by x to get rid of the fraction. And then whatever's left will be our final answer. So let me ask you this. On this part here, is there any numbers that the x cannot equal since I got a fraction?
Well, it's still going to be 0 because 3 times 0 would be 0. So you can't have 0 on top, right?
Oh, no. You can have 0 on top. You
Oh, okay.
you
2 on the bottom.
Yeah, so what'll make that a 0 on the bottom?
2. Positive 2.
Positive 2. So yeah, only focus on the bottom, remember, because you can do your calculator, you can do 0 divided by 5. It'll give you 0. You just can't do 5 divided by 0. That'll give you the error, okay? So for this one, the domain, I cannot be 0 and I cannot be 2. So y'all watch how I kick out two numbers. I'm going to start at negative infinity. So which number do I hit first? Going left to right.
0.
All right, so we're going to union around 0. From 0, I'm going until I hit 2. 2's my next number I can't be. So I'm going to union around to 2. So notice for each number you kick out, you got to union it. Now, from 2, I'm heading off to what?
Infinity.
Infinity.
All right, so the union thing is actually the infinity. That is to be able to create a range of numbers that cannot be used.
Right.
Okay.
So right here, so when you got two numbers, you got 3 intervals. I can go all the way from negative infinity. Remember, the curvy parentheses means it don't equal that 0, but you can go from negative infinity all the way to negative 0.0001 if you want to. You just can't be 0, right? Now, on the other side of 0, I can start at 0.001 positive, go from that number almost all the way up to 2. So I can go to 1.99999. I just can't equal 2. Okay, so then I start on the other side of 2. I can start at what? 2.00001 if I want to. But from that point on, there's nothing else I'm kicking out. So all numbers are good up to infinity. So remember, any numbers I'm kicking out, that's why I'm using the curvy parentheses. And then later on in life, if I want to include a number, I'll use brackets, okay? But we don't have to worry about that until we do the square root stuff later in life. All right, y'all. So now we got to find what? G of f of x. So that's going to be like doing G of f of x, which means first I got to do f of x. So I'm going to pull this down just a little bit. So f of x they gave us was what? F of x is up here. It's 3 over 1 minus 2x. So like I did a while ago, I said that x couldn't be 0, but now here, it's hard to figure out what number x can equal. But we can do this, right? Set 1 minus 2x equal to 0. Whatever answer I get, I will kick out of my domain because of that. So y'all, let me ask you, I'm going to solve this. I can either move to 1 or move to 2x. So most of y'all like that x being on the left side. So if you like the x being on the left side, you would move to 1 by subtracting it. So that'll give you negative 2x equals negative 1. Then divide both sides by the negative 2. So that tells me x cannot equal. Remember, them two negatives will make that a positive. So at this point, we know that x cannot equal a 1/2. But if you put a 1/2 in here, 2 times 1/2 is 1. 1 minus 1 makes that a 0. All right, so guess what? I now need to find g of this. So g of 3 divided by 1 minus 2x. Notice my g equation was 1 over x up here. So that's going to give me 1 over x, which is 3 divided by 1 minus 2 over x. Now I'm going to show y'all a trick. This is a single fraction on the bottom of this. It's still a complex fraction, but I can do it different than I did the one up here. Because what's the rule for dividing fractions?
Don't you multiply it?
Yeah, I'm going to change this to multiplication. And then the second fraction, I'm going to flip it, right? So this would be, in the 1, you can treat that like a 1 over 1 if you want to. change it to multiplication, you're gonna flip this fraction so that you get 1 minus 2x over 3. And y'all look at this. 1 times anything is the anything. So this will end up 1 minus 2x over 3. Y'all check this out. I got another fraction. Are there any numbers I need to exclude from this fraction? So let me ask you this. Can that 3 ever be changed?
No.
No, there's not a variable in the bottom of this one, right? So if the variable is not in your denominator, then you're not worried about it in the domain. So the final answer for G of F was that. Only number I got to kick out is the 2. So who wants to give me my domain?
Negative infinity. 2.
Oh, it wasn't 2. My bad. My bad. That's another problem. It was the 1/2 here.
Yeah, I'm like,
No, you're right. It's the
1/2,
Uh-huh.
and then U,
Uh-huh.
1/2 infinity.
There you go. Now, MATLAB will give you the infinity symbol. When you click in the answer blank, it brings up that helper bar on the bottom that lets you do fractions and exponents. If the infinity is not showing, just hit more, and it'll pull all the symbols up, and you'll find that infinity in that for sure, okay? All right, so that was 9-1. Now we're going to play with 9-2. So let me let y'all catch up on that real quick. And I'll tell you, the rest of this first test material, we don't have to worry about graphing. So that seems to be what was giving people the most headache, was the graphing. So let me get back up here. And we'll start with 9-2. So 9.2 is going to deal with inverse functions. So first, before we get into the functions, we're going to deal with inverse of a relation. So to find, but this principle, we'll use it later when we do the functions. So first, to find the inverse of a relation, we simply switch the X and Y values for each ordered pair. Now these are going to write in parentheses. So here we go. So my first example, I'm going to find the inverse of the relation. Now, the ordered pairs they're giving me, they always use these fancy parentheses, was -9, 2, -7, 7, -2, 9, and 5, -5. So y'all, the answer will be ordered pairs also. So what's the first ordered pair going to be?
2, -9.
And then next,
7, -7.
so y'all got the idea. All we're doing is switching them X and Y values. So that makes this what, a 9, -2, and then finally my -5 and my 5. Okay. Now, knowing what I did here, switching my X and Y's around, see if you can do this one. Find an equation of the inverse relation. And they're giving me X to the third power of Y equals -7. And y'all are going to do one move, and that's what? We're going to switch.
Are we just doing y x cubed then?
Well, you're really close. I'm going to switch the X into Y, right?
Yeah.
But when I switch them, that exponent stays where it was.
Oh, okay.
So that's going to give me what? A Y to the third X equals -7. So instead of the X being cubed, now we got the Y being cubed multiplied by the X, okay? They're not that bad. On them first two problems, that's all you're doing. Switching those X and Y's and you're done. So y'all remember first part of this, I guess it was week 1, we did the vertical line test to tell if there was a function. So in reality, for a function to have an inverse, it's got to be what we call 1-to-1. And what 1-to-1 means is that each Y value can only have one X value. So to figure that out, we use what we call the horizontal line test. So remember, horizontal lines go straight across. So remember, 1-to-1 means each Y value can only have one X value. So what we do on this horizontal test, if a horizontal line intersects a graph more than once, the graph is not 1-to-1. Okay, so that means it's a function because the X's can only have one Y value. It's 1-to-1 because my Y values can only have one X value, okay? So I'm going to give us some graphs and we're going to see whether we think they are 1-to-1 or not. So determine if the graph is 1-to-1 using the horizontal line test. All right, y'all, so my first graph, we'll have my X and my Y. So this one is a curvy line steadily going uphill. So any guesses whether that is 1-to-1 or not? So here's my horizontal line.
That is 1-to-1.
It is definitely, because it only
Yeah.
intersected once, no matter where I go on my graph, it's intersecting at one time on that horizontal line. So good job. Now it's a little flatter looking here, but it is still going uphill. So definitely that one's a yes. So let me try this. This one sort of curves down here. Curves down here. So that looks like an upside down parabola. So what's y'all's guess?
No, because it's the horizontal line's going to intersect it twice.
Yeah, it's going to hit it twice. Now let me ask y'all this. What if I if I restrict the domain, what if I did something like that?
It looks like it would still be what, I'm sorry?
So X cannot be negative on this problem, so we're only looking at the positive X's. In this sense, it does pass, right?
Yes.
So if I restrict the domains, I can make something that's not one-to-one become one-to-one. So I can say, hey, X has to be greater than or equal to 0. If I do that, I'm only looking at the right half of the graph, which would make it that way, okay? So we can manipulate these if we need to, and you'll see that happen later on, okay? In one of my examples. So we're going to start dealing with the functions. So let me give you some rules here. This is how we find, so this is going to be finding an inverse function. Now, to represent inverse function, we use f of -1 of x. So that's not an exponent or nothing. That's just notation letting me know that this is my inverse function when I'm done, okay? Now, the first requirement, function must be 1-to-1. And y'all, I'll tell you a trick. On this homework, when you're finding an inverse function and it asks you if it's 1-to-1, you're going to put yes every time. All of these are going to be 1-to-1. So since it's 1-to-1, our first step in finding that inverse function, we're going to replace the f of x with a y. Remember, f and x and y are the same thing, okay? Now, what did we do? We'll go to those relations. How did I find those inverse relations, Walgo?
Swapped them, switched them
So
up.
guess what? At this point, once I replace f of x with y, I'm going to switch the x into y. Or do a quick swap, right? Once I switch that x and y, I will solve for the y. Once I solve for the y, my last step, I'm going to replace y with my f inverse notation, which is f -1 of x. Now, I will say this, in MATLAB, they give you the f -1 of x equals, all you got to put is the actual inverse function you get, okay? So starting at about number 7, their questions will be this. Determine if 1-to-1. Part B, if it's 1-to-1, you're going to find the inverse. Now, I'll graph these to sort of show you why they're 1-to-1, but these start at number 7. So you're going to have to find inverses for all these though, remember. So if you put option B that says it's not 1-to-1, it's going to mark y'all wrong, okay? So f of x is going to equal x plus 2. So y'all, if I was to graph that, I would go to my y equals, clear that out, and I would put in my x plus 2. And I just want to see the graph, so I'll hit enter. So look, that's a straight line. If you run a horizontal line down, y'all, that's definitely 1-to-1, okay? So we will find it inverse. So my first step, I'm going to replace f of x with a y. So that's going to give me y equals x plus 2. All right, my next move. Swap X and a Y. So we're just gonna swap them around. So that's gonna give me X equals Y plus 2. All right, so we switch to X and Y. Now we're gonna solve for Y. So y'all, one move will get this Y by itself on the right side. What would y'all do?
Subtract 2 from the other side.
I'm gonna subtract 2 from both sides. So I end up with X minus 2 equals my Y. So now we go to the last step, replace Y with inverse notation. So F negative 1 of X will equal X minus 2. Now all you're gonna put in MATLAB is the X minus 2. And I'll tell you something about inverses. Inverses always have pretty much the opposite sign than the actual function. So if the function's adding, the inverse will probably be subtracting, okay? All right, y'all good on that one? They're not too bad. You just gotta replace the f of x with the y, swap them, solve for the new y, and then you get your final answer. All right, so from 9, I went to y'all's number. I mean, from 7, I went to y'all's number 9 next. 8 is the same thing as that one, pretty much. So this one is a little trickier, so I wanted to get this one out of the way. F of x equals 5 over x plus 9. So if you graph that, you would see that it would be 1 to 1. So I would go to y equals, there's that. 5 divided by, now since you got 2 parts on the bottom here, you got to put the x plus 9 in parentheses. Unless you do the other way, which was alpha y equals, it gives you a format of a fraction. You can put the 5 on top, x plus 9 on the bottom. But y'all be careful, if you do it the way I just did this, the x plus 9 has to be in parentheses. Hit graph. So it's got a part over here sort of coming down. This part comes down and it slowly tries to get to the 0, but it still is never what I would call horizontal. It does pass the horizontal test. So this one is 1 to 1, so we're going to find our inverse. So y'all, I'm going to start out by replacing that f of x with a y. So I get y equals 5 over x plus 9. So what would y'all do next?
Do the x plus 9 equals 0.
Oh no, you're not finding you're not finding the domain on this, so you don't have to do that. But remember, this is the point where I swap, right? I'm going to swap the x and the y around. So that's going to put the x up here, and that's going to equal 5 over y plus 9. So that y is in the denominator of this fraction. So I'm going to show you a trick to get the y plus 9 from the bottom of this fraction and up top. What you want to do to this, multiply both sides by y plus 9. Remember, I wanted to get rid of the x, which was the denominator, so I multiplied everybody by x. This time, since y plus 9 is in my denominator, I'm going to multiply both sides by y plus 9. So that'll give me y plus 9 times x on the left side, the y plus 9 times the 5 over y plus 9. So the first thing, what happens here?
They cancel out.
And y'all, I'm not going to distribute this. I'm just going to leave this like it is. Y plus 9 times X equals that 5. If the variable I was solving for was the X, I probably would have distributed it. But since I'm looking for the Y that's inside these parentheses, check this out. This Y plus 9 is being multiplied by that X. So what I'm going to do is I'm going to divide both sides by X. If I divide both sides by X, it eliminates the X on the left side. So I undo the multiplying by dividing. So y'all, that'll give me Y plus 9 times X divided by X equals 5 divided by X. So guess what? The left side, those cancel out. So since all I got left is this Y plus 9 in parentheses, at this point, I can actually drop the parentheses, right? So that I get a Y plus 9 equals 5 over X. Now, y'all, here was my original when I started. This is what I'm with now. All we did in the long run is we took the Y plus 9, put it up here, and the X went to the bottom. We flip-flopped them. So here's, I got Y plus 9 equals 5 over X. What are you going to do to get that Y by itself?
-9.
There you go. So we're going to subtract 9 from both sides. So Y, whoops, I can just come under here and do -9, -9. So to cancel out over here, leaving my Y. Can't do nothing with that. They're not like terms. So I'm just going to write that 5 over X minus 9. Final step is to turn that Y into a F -1 of X. So replace Y with F -1 of X. Y'all can't do nothing to simplify that, so we're going to make that a 5 over X minus 9. Final answer. I'm not going to lie, that's probably the trickiest one on this homework. Is that one right there, okay? Not going to give y'all a second to catch up. It looks like I got one. So I got about 3 more of these, but they're a little easier. All right, so I think this was like number 10. F of X equals X to the 3rd minus 4. So here we go. Replace F of X with a Y. Switch that X and Y, so you get X equals Y to the 3rd minus 4. So now to solve for this Y, we need this Y to the 3rd by itself. So when I solve this, my first step is to come in and add 4 to both sides. So I add my 4. So y'all, that's going to give me X plus 4 over here. All that's left on the right side is a Y to the 3rd. So here's my question for this one. How can I turn a Y to the 3rd power into just a Y? So what do y'all think undoes exponents? So have y'all ever heard of a cube root? So for this problem, I'm going to take a cube root of each side. Remember, to undo exponents, I do the roots, and the root matches whatever the exponent was. So if this was a 2, I'd have took a square root. A cube root, I mean a cube, I take a cube root. If that was a 4, I'd take the 4th root. So I'm gonna come in and take a cube root of x plus 4 equals a cube root of y to the 3rd. Can't do nothing to the left side. But y'all, right side, the cube root cancels with the exponent 3, leaving me a y. So remember, to get rid of cube roots, we would raise it to the 3rd power. To get rid of stuff to the 3rd power, we take roots. They sort of undo each other. All right, at this point, I know what f negative 1 of x is going to equal the cube root x plus 4. So when you're doing this problem and you put in a cube root, you'll see a MATLAB helper tool looks like this. You got to come in and put the 3 there, and then arrow underneath and put in the x plus 4. All right, y'all, moving on. So this, I think, is number 11. Now check out this one. I wanted to definitely show you this. It's f of x equals 3x squared plus 2. And then they got a comma and says x has to be greater than or equal to 0. So they're giving you a domain restriction. That means we're not looking at no negative x's on the graph. We're only looking from 0 on. So when I graph it, I'll have to graph the whole thing. So let me go to y equals and clear that. 3x squared plus 2. So let's look at the graph. It's a parabola. Now the parabola wouldn't pass, but they said we can't look at negative x's. So this is what I showed y'all won't go. They're only counting the right half, which in that case is 1 to 1, okay? So that's why they did this right here. So it's 1 to 1. So replace f of x with a y. And let me show you this. On this one, they were nice, and they gave us this much of this answer. All we got to figure out, they gave you all this part of the answer. All we got to do is figure out what's going to go on top, okay? So we know when we're done, we're going to end up with a square root somewhere. So let's work this. Replace the f of x with the y. All right, this is on y'all. Next move.
Swap the x and the y.
There we go. We're going to swap them. So we get x equals 3y squared plus 2. All right, so the first move is to get the 3y squared by itself. So we're going to take care of that positive 2 by subtracting 2 from both sides. That's going to give me an x minus 2 over here. That's going to equal 3y squared. All right, one more step before I worry about that y squared. You got a 3 right here being multiplied by the y squared. So we need to come in and divide both sides by that 3. Y'all see what's happening? Can't do nothing here. But over here, the 3's cancel, and I'm left with a y squared. So how can I turn a y squared into a y?
Square root of 2.
There you go. I'm going to take square roots. There you go. So I got a square root, x minus 2 over 3 equals the square root of the y squared. I'm running out of room. Let me pull that up here. Can't do nothing to the left side. But square root of y squared is y. So y'all, my question is, what's going in the blank?
X minus 2.
X minus 2. So I thought it was pretty cool. They gave us most of that answer. We just had to figure out sort of what was going in that blank. And see, you got two in a row. This one has a y cubed, this one had a y squared. I did both of them the same way. I took a cube root here, took a square root here. Remember, if there's not a number in the notch of a radical, that means it's automatically a 2, okay? But we don't have to write the 2 because it's understood to be there. All right, y'all, guess what? Last problem, number 12. This one's not quite as bad, okay? This one has f of x equals the square root x minus 3. All right, same pattern, right? Change that to a y. Come in. Switch that x and y around. So remember, that's going to give me what? X equals a square root y minus 3. So I'm going to play with y'all a second here. While this is all under the radical, I can't add 3 to both sides yet. I got to get rid of that radical. So how will I get rid of that square root radical?
You square,
I'm going to square both sides. Good job.
yeah,
So squaring undoes radicals, radical undoes squaring. So to square both sides, that's going to give me an x squared over here is going to equal the square root of y minus 3. All that's being squared. So you can't do nothing here. That's an x squared. But y'all, this radical now cancels with that exponent 2. And all that's left is y minus 3. So when you square a radical, you get rid of it. When you cube a cube root, you get rid of it. All right, y'all, let's see. We're down to one step. So what's y'all's final
add
step?
3.
Add 3. So we want to add 3 both sides. So I get an x squared plus 3 equals my y. Oh, I didn't do that, did I? So I'm adding 3 to both sides. So that gave me x squared plus 3 here equals y. Can't do nothing else with that. So we get f negative 1 of x equals x squared plus 3. And y'all remember on this homework, you don't have to put in that f negative 1 of x. It's already there. You just put in our answers we're getting, okay? So y'all, that is 9.2. So let's see, that's all it's going to be due. Sunday night will be your 9.1 and 9.2 stuff. Like I said, once we come back Monday, we'll get into the chapter 3 for the week. Knock that out. The next week, we're playing with the test. And what I'm going to do, let me stop my share here so I can stop my video.